In this video, I will solve a nested floor equation taken from the Indian Olympiad Qualifier in Mathematics 2021. For any real number t, let the floor of t denote the largest integer less than or equal to t. Suppose that n is the greatest integer such that the floor of the square root of the floor of the square root of the floor of the square root of n is equal to 4. Find the sum of the digits of n. Before I dive into the solution to this problem, I would like to give some examples first on the floor of t, given some values of t. Okay? Now, the value of this is always an integer. Okay? Now, how do we determine that integer value? It depends on the value of t. Okay, so if t is already an integer, then the floor of that integer is the integer itself. For example, the floor of 5 is equal to 5. Okay? Um, the floor of 6 is equal to 6. The floor of 0 is equal to 0. The floor of negative 7 is equal to negative 7. Now, what if the value of t is non-integer? For example, the floor of negative 1.5. We always take the largest integer less than negative or less than this number. So what's the largest integer less than negative 1.5? The answer is negative 2. So the floor of negative 1.5 is negative 2. How about the floor of negative 0.5? The floor of negative 0.5 is negative 1 because negative 1 is the largest integer less than negative 0.5. Okay, another. What if we have the floor of 0.2? The answer is 0. 0 is the largest um, integer less than zero point 0.2. Okay, so that is what we mean by the floor of a number or the floor of t. Now let's have the solution to the nested floor equation with this idea. Okay. Um, okay. So how do we approach this problem? Take note that the expression in the left side is equal to 4. So it means that this expression inside is between 4 and 5. In other words, the square root of the floor of the square root of the floor of the square root of n is greater than or equal to 4 but less than 5. Okay? Now, let's square both sides. Let's square the three parts of the inequality. So, we obtain the following. So, this is 16. And then we have the floor of the square root of the floor of the square root of n. And then this is less than 25. Take note that we are maximizing n. Okay, we need the largest possible value of n. Now, based on this inequality, the value or the values of this quantity at the middle are as follows. The possible values. We have the value 16, 17, 18, up to 24. Now, how do we maximize n? We need to choose the largest possible value of this quantity at the middle, which is 24. Okay? So, if the value of this is 24, it follows that the square root of the floor of the square root of n is greater than or equal to 24 but less than 25. Now let's square the inequality to get rid of the square root symbol. Square, square. Okay. 24 squared is 576. Let's use another color. Okay. So the square of 24 is 576. So we have the floor of the square root of n less than 625. Okay. Now, similarly, the values of this, or the value of this quantity in the middle, can be 576, 577, all the way to 624, because we cannot have 625. Okay, take note, we have this less than symbol at the right endpoint. Okay, now again, we need to have the greatest value of n, so we choose 624 as the value of this quantity at the middle. Okay, so if 624 is the value of the floor of the square root of n, then it follows that the square root of n is greater than or equal to 624 but less than 625. Okay, let us square the inequality one more time to get rid of the last square root symbol. So square, square, square. The square of 624 is 389,376, and then we have n less than 390, 625. Okay, so we have now the range of the values of n. Now what's the largest possible value of n based on this range? The largest possible value is 390,624. Okay, because we cannot have this one. Take note, we have the less than symbol here. Okay, now the question is, the item is asking us to find the sum of all the digits of the largest possible value of n. So the sum of the digits is, so this is 12, this is 12, this is 12, so we have 24. And this is our final answer.